All right, guys, so we want to solve this problem. We've got ourselves a beam of singly charged positively oxygen atoms was accelerated by a potential difference of 1.1 by 10 to the 4 volts. It enters the magnetic field of a mass spectrometer if the field has a flux density of 7.2 by 10 to the negative 2 Tesla and the path radius is 0.850 meters. Calculate the mass of the oxygen atom. So let's look at this. What have we got? We've got ourselves these positively charged oxygen atoms. They're moving into a field, and this field has got magnetic field out of the page, like so. And so we see that there is a circular motion of the oxygen atom, and the radius of that is 0.85 meters. So from here to here, 0.85 meters. That's what we've got. Calculate the mass of the oxygen atom. So we go to our first equation. We think to ourselves, what's the first and best equation? R equals mv over bq. And that works pretty well for us, except for there's one problem. In the question, they do not give us the velocity, and in the question, they do not give us the mass. So this equation doesn't help us very much. They don't give us the velocity, they don't give us the mass. Are there any other equations that we can work with? Okay, so some other equations in our toolbox. We know work equals VQ. If you accelerate a charged particle with an electric field, then the change in kinetic energy, the work done, is equal to the voltage, the potential difference you accelerated it through, multiplied by the charge on the particle. So that might work for us. Do we have voltage? Yes, we do have voltage. So we've got voltage. We know the charge of the oxygen atoms are positive 1.6 by 10 to the negative 19 coulombs. So we know that. So that's something we've got. What is work? What is work? Work is what's been done to these charged particles. They've gone from sitting just quietly doing nothing to being really, really fast. So they've gained kinetic energy. So now we can use that to our advantage. Let's explore that and see what happens. A gain in kinetic energy, they now have kinetic energy because they had none. V squared equals VQ. Let's make sure we differentiate between capital V and lowercase v. Lowercase v is velocity, capital V is voltage. All right, we got the same problem. We don't know what mass is, we don't know what velocity is. We got the same problem over here. We don't know what mass is, we don't know what velocity is. So you know what we're going to do? We're going to see if we can use these two equations, two different equations, both with two variables unknown, but they're the same variables unknown. So we're going to now rearrange this equation. It's mass that we're looking for. We don't care about velocity really. So we're going to rearrange the equation as an expression of velocity. Let's do that. Is that correct? Is my algebra correct? Yes? All right. Is my algebra correct again? Yep, sing out if it's not, because it's not always. We know that. Okay, so now we know velocity of these charged oxygen atoms is equal to that. Velocity is equal to that. These two values are the same, which means that this is the same as that. Let's put them together and see what happens. Okay, so we know the magnetic field, we know the charge, we know the radius, we know the voltage, we know the charge, we don't know the mass, we don't know the mass. But now we have one expression, that's one expression with one variable. We can solve this for mass, and that'll give us the mass of the charged particle. Do you guys want to do that now? What do you mean, no?
No, I have to.
I got to that point, but I couldn't figure out how to solve for M for some reason.
Okay, so we've got this big chunky square root sign here. We want it to disappear.
Yeah.
How do you make a square root sign disappear?
Sides, but yeah.
Square both sides, so then we end up with b squared, q squared, r squared over m squared equals 2vq over m. Straight away, that guy cancels that guy cancels that guy. Flip them, capital V
Yep.
for voltage. Okay, then you take these guys, send them across, and you end up with mass is equal to B squared Q R squared over 2 times the voltage. Plug in your values, you've got your mass of the charged oxygen particle.
I'm doing a curtain webinar thing on Wednesday.
Oh yeah, that thing.
But
What's that mean?
literally, all you